Let's begin by examining the major components used in Foveros packaging. This is the printed circuit board, or PCB. The PCB provides electrical connections and mechanical support for the entire package. Next is the ball grid array, BGA. The BGA uses tiny solder balls to connect the package to the PCB, enabling electrical communication. Here we have the substrate, which acts as a foundation inside the package. It distributes signals, provides mechanical support, and serves as the interface between the dies and the PCB. These small metallic bumps are C4 microbumps. They are ultrafine solder structures used to connect substrate and high-density configurations. This layer is the interposer, which facilitates communication between multiple stacked components. This layer is C2 microbumps. They are ultrafine solder structures used to connect dies to each other. And finally, this is the compute die, the main processing chip responsible for performing computational tasks. We now move into the FoverosAssembly process. The first major step is photolithography, a fundamental technique used to create microscopic circuit patterns on silicon wafers. The process begins by coating the wafer with a light-sensitive material called photoresist. A photomask containing the desired circuit pattern is precisely aligned over the wafer. When exposed to ultraviolet light, portions of the photoresist undergo chemical changes. In the development step, the exposed photoresist is washed away, leaving behind the patterned areas. Photolithography is the foundation of chip manufacturing, enabling the creation of extremely fine circuit features. The next stage is etching, where the pattern created during photolithography is transferred into the wafer material. Etching selectively removes exposed regions of the wafer, forming vertical structures such as trenches or holes. Once the etching process is complete, the remaining photoresist is stripped away, revealing the patterned wafer. At this point, the etched vertical columns inside the wafer are empty. We fill these structures through electrode deposition, typically using copper. This creates through-silicon vias, or TSV, vertical metal-filled connections that run through the silicon. TSVs enable vertical electrical connections between stacked chips. After electrode deposition creates copper pillars on the base die, wafer bumping adds external solder bumps to enable chip-to-package connections. Solder bumps are deposited on top of the copper pillars through electroplating. Because the deposited solder may not be perfectly smooth, the wafer undergoes reflow, where heat melts and reshapes the solder into uniform dome-like bumps. After bumping, we attach the compute die to the base die, or interposer. This is done through thermal compression bonding, a process that uses heat and pressure to join the two dies with high precision and strong mechanical integrity. This marks the beginning of the 3D stacked structure characteristic of Foveros technology. Once the dies are bonded, the next step is to expose the through-silicon vias, TSV. In manufacturing, this is achieved by mechanically grinding and polishing the top surface of the stack until the metal TSV pillars are revealed. This allows them to serve as connection points for the next layers of metal and solder. With the TSV pillars exposed, we repeat the process of electroplating and reflow. Additional solder is deposited and then melted to form strong, reliable connections. This prepares the stacked die for integration onto the substrate. The final step is to attach the completed die stack onto the substrate. The solder bumps on the underside of the stack are aligned with the substrate pads, and the stack is then bonded in place. This creates the full vertical hierarchy, from the compute die to the base die to the substrate, and finally to the PCB. The result is a fully assembled Foveros module. In this lesson, we explored the structure and assembly process of Foveros advanced packaging. By combining 3D stacking, TSV technology, and precise bonding techniques, Foveros enables high-density integration, improved performance, and efficient power delivery. Thank you for watching, and we hope you continue to explore more about advanced semiconductor manufacturing.